So you're sitting on a mountain of data, right? Piles of CSVs, a database that's just jam-packed. But let's be real, what do those raw numbers actually tell you? Not much, huh? The real trick, the real magic, is finding the story that's hiding inside of it. So, okay, let's dive in and see how a really cool tool can help us do exactly that. And that really is the central question, isn't it? You've got all the sales figures, all the user metrics, the results from your latest experiment. It's all there. But so what? How do you actually get from a spreadsheet that makes your eyes glaze over to a genuine aha moment? All right, so here's the game plan for our little journey today. First, we're going to break down what statistical modeling even is. Then, we'll get into our main toolkit for the job, StatsModels. After that, we'll see it in action, modeling relationships, and even predicting the future. And finally, and this is super important, we'll cover how you can prove your story is actually the right one. Okay, let's kick things off with the big idea here. What in the world is statistical modeling? Well, it's really about a fundamental shift in how we think about our data. Yeah, think of it like this. We're officially graduating from being data collectors to being data detectives. We're not just bagging up the evidence anymore, we're on the case, figuring out how all the clues connect. Asking the important questions like, if I tweak this variable over here, what happens way over there? That's the mystery we're here to solve. And, any good detective needs a great set of tools. If you're working in Python, one of the absolute best kits you can have is StatsModels. Seriously. You can think of it as your own personal forensic kit, but for data analysis. So what's actually inside this toolkit? Well, at its heart, StatsModels is a Python library that hands you pretty much everything you need for serious statistical work, all in one convenient package. It's built from the ground up to help you create models, rigorously test your ideas, and just dig into your data with a ton of confidence. So why would you reach for StatsModels? Well, there are three huge reasons. First, you get results you can actually walk into a meeting and explain to other human beings. That's called interpretability, and it's a big deal. Second, the methods it uses are rock solid and trusted by statisticians. That's reliability. And third, this isn't some dusty academic tool. It's a powerhouse used every single day in finance, data science, and all sorts of research. And you know what's great? Getting started is ridiculously easy. It's literally one line in your terminal to install it and one line in your code to bring it in. The barrier to entry here is practically zero, so you can just jump straight into the fun part, the analysis. All right, toolkit's open, let's put it to work. We're going to start with one of the most fundamental tasks in all of data analysis, figuring out how different things influence each other. And we do that using something called regression. This is the classic example, and it's perfect. Let's say we want to know how the square footage of a house affects its price. Well, the price depends on the size, right? So that makes price our dependent variable, and the size is the independent one. Regression is the tool that lets us map out that exact relationship. And the beautiful thing about StatsModels is that it has a model for just about any situation you can think of. If you're trying to predict a continuous number, like a house price, you'll use linear regression. If you're trying to answer a yes or no question, like will a customer cancel their subscription, you'll use logistic regression. And for those trickier, more complex scenarios, you've got generalized linear models. No matter the problem, the library's got you covered. But what if your data isn't just a simple snapshot in time? What happens when it's constantly changing day by day, hour by hour, like a stock price or your company's daily sales? For that, we need a whole different set of tools. So let's jump into the world of time series analysis. This is for any kind of data that has a timestamp attached to it. Just think about trying to forecast next quarter's sales based on the past 5 years of data, or predicting where a stock is headed, or even what the temperature is going to be next week. These are all time series problems, and they are everywhere. And StatsModels gives us the fundamental building blocks to tackle this. You've got your AR, or autoregressive model, which is based on a really simple idea. What happens next is probably related to what just happened, so it looks at past values. Then you have the MA, or moving average model, which is a bit different. It cleverly looks at the mistakes from our past predictions and uses those errors to make the next forecast even better. And very often, we blend these ideas together. Let's say your data has an obvious trend, like sales are just generally going up over time. Well, for that, you'd use a model called ARIMA. The I in the middle stands for integrated, which is really just a fancy way of saying the model is smart enough to first account for that overall trend. By getting that out of the way, the AR and MA parts can do their jobs much more effectively. And honestly, that can be the difference between a useless forecast and one you can actually build a whole business strategy around. Now, let's talk about maybe the most critical part of this whole process. You've built your model, it's telling you a story about your data, but is it the right story? How can you actually be sure? This is where we have to put our assumptions to the test. StatsModels gives you two main ways to do this. First up, you've got descriptive statistics. Think of this like giving your data a quick checkup. You're just checking its vital signs. You know, the mean, median, variance, that sort of thing. But for a much deeper diagnosis, you use hypothesis testing. This is where you get to put your theories on trial with some serious mathematical rigor. And this is really the heart of all statistical detective work. You always start with a null hypothesis. That's your default position, your starting assumption. It basically says, there's nothing to see here, folks. Any pattern you think you see is just random luck. Then you use your data as evidence to see if you can confidently reject that idea and through the alternative hypothesis, that yes, there is a real, significant effect going on here. And believe me, the library is packed to the gills with these kinds of tests. Whether you're using something like ANOVA to compare the average results from different groups, or a Durbin-Watson test to sniff out hidden problems in your time series model, StatsModels gives you all the tools you need to double-check your work and be truly confident in your conclusions. So let's bring it all home. Why does any of this really matter? Well, it's because StatsModels gives you clarity. You get results you can actually explain. It gives you reliability, built on a foundation of proven statistical methods. But most importantly, it gives you power. The power to move beyond just describing what your data is and to start truly understanding the story it's trying to tell you. So, now you have the toolkit. The next time you're staring down a spreadsheet, I want you to see something different. Don't just see a grid of numbers, see the potential for a story. Ask yourself, what hidden patterns, what future trends are just waiting in my data for me to finally uncover them?